The year is 2023 and the Earth's temperature has already risen by more than 1 degree Celsius since the pre-industrial era. This might seem like a small change, an almost negligible blip on the thermometer of our planet. However, this seemingly insignificant increase is fueling a cascade of consequences that are being felt in every corner of our world, including the skies above. One of the industries most intricately intertwined with our changing climate is aviation. It is an industry on the front lines of a warming world, grappling with the profound implications of a hotter, more turbulent atmosphere. The aviation industry, a symbol of human ingenuity and our ability to conquer distance, now finds itself at a critical juncture. The very forces that lift airplanes into the sky, air pressure, wind patterns and atmospheric stability, are being altered by climate change. This is not a distant threat. It's a present reality that is already impacting flight routes, aircraft performance, and the very experience of air travel. The once familiar blue canvas of the sky is becoming increasingly unpredictable, marked by more frequent and intense storms, shifting jet streams, and rising levels of turbulence. While passengers might experience these changes as a slight inconvenience, a bumpier ride, or a longer flight, the implications run much deeper. These atmospheric shifts have the potential to disrupt global air travel, leading to flight delays, cancellations, and increased costs for both airlines and passengers. The economic repercussions are significant, but even more concerning are the safety implications of flying in a climate-changed world. As our planet continues to warm, the aviation industry is faced with a stark choice: adapt to the new realities of a changing climate or risk being grounded by them. The future of flight, it seems, hinges on our ability to understand and mitigate the impacts of climate change, paving the way for a more sustainable and resilient aviation industry. One of the most immediate and noticeable impacts of climate change on aviation is the increase in turbulence. Clear air turbulence, which is particularly dangerous due to its invisibility to pilots and onboard radar systems, is projected to become more frequent and severe as the planet warms. This invisible threat lurking within seemingly calm skies poses significant risks to passenger and crew safety, potentially leading to injuries and damage to aircraft. Beyond the discomfort of a bumpy ride, climate change is also altering flight paths and increasing travel times. The jet streams, those fast-flowing air currents that airlines rely on for fuel efficiency, are being disrupted by a warming Arctic. As the temperature difference between the equator and the poles decreases, the jet streams weaken and meander, forcing pilots to take longer routes and consume more fuel. This not only increases operating costs for airlines, but also contributes to higher carbon emissions, further exacerbating the problem of climate change. The performance of aircraft is also being impacted by rising temperatures. Warmer air is less dense, which means that airplanes require longer runways for takeoff and have reduced weight limits, particularly in hotter climates. This can lead to restrictions on cargo capacity and even passenger loads, impacting the profitability and efficiency of air travel. Furthermore, extreme heat can also stress aircraft engines and other critical systems, potentially leading to more frequent maintenance and shorter lifespans for these expensive assets. Despite the challenges posed by climate change, the aviation industry is not standing idly by. Airlines and aviation authorities around the world are actively exploring and implementing various strategies to adapt to the new realities of a warming world. These efforts range from technological advancements to operational changes, all aimed at mitigating the impacts of climate change and ensuring the safety and sustainability of air travel. One of the key areas of focus is the development of more fuel-efficient aircraft. Airlines are investing heavily in next-generation aircraft designs that incorporate lighter materials, aerodynamic improvements, and more efficient engines. These advancements are already starting to yield results, with newer aircraft models boasting significantly lower fuel consumption and emissions compared to their predecessors. However, the transition to a new fleet of aircraft is a gradual process, and more radical solutions are needed to achieve significant reductions in aviation's carbon footprint. Another area of innovation is in air traffic management. By optimizing flight paths, reducing congestion in the skies, and implementing more efficient takeoff and landing procedures, air traffic controllers can help airlines save fuel and reduce emissions. These operational changes, while seemingly small, can have a significant cumulative impact on the environmental performance of the aviation industry. In addition to technological and operational changes, the aviation industry is also exploring the use of sustainable aviation fuels, or SAFs, as a way to decarbonize air travel. SAFs, which are derived from renewable sources such as biofuels and captured carbon emissions, have the potential to significantly reduce the life cycle emissions of aviation fuel. While still in their early stages of development and deployment, SAFs hold immense promise for a greener future for aviation. Amidst the challenges and uncertainties, a beacon of hope emerges from the heart of the aviation industry. A new generation of innovators, engineers and policymakers are working tirelessly to chart a more sustainable future for aviation, one that decouples air travel from its reliance on fossil fuels and paves the way for carbon-neutral or even carbon-negative flights. One of the most promising breakthroughs in recent years has been the development and successful test flights of electric aircraft. While still in their early stages, electric aircraft have the potential to revolutionize short-haul air travel, particularly for regional routes and commuter flights. These aircraft, powered by batteries instead of jet fuel, produce zero emissions during flight and significantly reduce noise pollution, offering a quieter and cleaner alternative to conventional aircraft. Another groundbreaking development has been the emergence of hydrogen-powered aircraft. Hydrogen, when used as a fuel, produces only water vapor as a byproduct, making it a truly clean energy source. Several major aircraft manufacturers are investing heavily in hydrogen propulsion technology, with prototypes and test flights already underway. While challenges remain in terms of infrastructure and storage, hydrogen-powered aircraft hold immense potential for long-haul flights and could play a pivotal role in decarbonizing the aviation industry. The journey towards a sustainable future for aviation will undoubtedly be complex and challenging, requiring collaboration, innovation, and a steadfast commitment from all stakeholders. However, the recent breakthroughs and the unwavering determination of those working to reshape the industry offer a glimmer of hope that the skies of tomorrow can be both busy and blue, filled with aircraft that soar above our heads without leaving a trail of carbon emissions in their wake.